Okay, everybody, how's everybody doing? Hopefully being really nice and good to the substitute. If not, you'll be in trouble with me. All right, today's notes. Let's take a look at 416.19. So today's objective has to do with finding the characteristics of a triangle mid-segment. Okay, I'll give you a second to write that down. But finding the characteristics of a triangle mid-segment. Okay, so what's a mid-segment? Well, all a mid-segment is just a line segment. All it is a line segment whose endpoints are at the midpoint. Just a line segment. Okay, but of a triangle mid-segment, then let's draw a picture. Okay, a triangle mid-segment then would look like this. So it's a line segment whose inputs are at the midpoints. So let's draw a picture. Okay, try not to draw an isosceles triangle. Try not to draw an equilateral triangle. Try and draw something that doesn't look like it, because then it's just too general. So I'm going to draw a triangle, okay? And I'm going to label it A, B, C. Okay, go ahead and draw that. Now, to get a mid-segment, and I'm going to use my ruler. You don't have to do that, but I'm going to do it for a little bit of accuracy. I'm going to actually find the middle, okay? So I'm going to use my ruler. It looks like about 4.4 here for me. So half of that would be a 2.2. So that's my midpoint. Okay, that's my midpoint. I'm going to label that X. Midpoint. I'm going to get the midpoint of AB, so I'm just using my ruler. I've got about 4.2, and half of that would be about a 2.1. Okay, so I just used my ruler. I measured it. I got half of it. Okay, 4.2, half of that's 4.1, let's label that Y. So a mid-segment then is to connect to a line segment whose endpoints are at the midpoint. So it's right there. So I'm going to go ahead and draw that in. Right, there's my mid-segment. So XY is my triangle mid-segment. So XY is a triangle mid-segment. Okay, now there's two things that are important about the triangle mid-segment. Two things we want, okay? First star, it turns out it's half its base. Half its base. So if this is 10, this would be 20. Or if this were, say, 18, this would be 9. It's just half the length. So it's going to be half the length of its base. Okay, as an example, I don't know, say this is 24. I'm just using a pencil. I'm just making these numbers up, just making them up. 24, and that'd be 12. It's half. That's all, okay? It's that easy. I'm just going to take half, okay? Now, there's a second thing that's important. The second thing has to do with the fact that it happens to be parallel to its base. And it looks parallel, doesn't it? Doesn't it look parallel? So we're going to write that. Here's a new symbol for you. We're going to say XY, line segment XY, is parallel. Okay, see that? That's the symbol for parallel. It's parallel to AC. Okay? Now, since it is also mid-segment, there's one more thing that we're going to put in here, and that is we know if it's a midpoint, we know that this side, BX, is equal to this side, XC, because that's a midpoint, right? So those have to be equal. And the same thing on the other side, this side, BY, that's a midpoint, has to be equal to YA. Has to be, because it's a midpoint, okay? So there's some things we can tell and know about a mid-segment, okay? So let's look at example 1 and actually do some work on a mid-segment, okay? So first of all, let's graph it. Okay, we're going to go to -6, 1, 2, 3, 4, 5, 6, 1, point A. B is at -2, 1, 2, 3, 4, 5. There's B, and C is at 2, -1. There's C. Okay, I just graph my points. I'm going to connect my dots. Connect my dots. And connect my dots. Okay, there's triangle ABC. So first thing I'm going to do is find the midpoints, because we're looking for mid segments. So if I want to find the midpoint of AB, BC, and AC, the easiest way to do it is by counting. Okay, so I'm going to count from A to B. So I count from A to B, it's up 1, 2, 3, 4, and over 1, 2, 3, 4. Okay, 4 to 4, but half that journey because I want a midpoint would be 2, 2. So right there is the midpoint of AB. Let's call that X. Okay, so the midpoint of AB is at X. So the midpoint is going to be at, it's going to be at the point 1, 2, 3, 4, -4, 3. Okay, there's the midpoint of AB. Okay, let's find the midpoint of BC. Well, that's easy. Let's count it. So let's count from B to C. Let's go 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 4, 6. Let's go 2, 3, puts me right here. Let's call that Y. So we found the midpoint of Y. The midpoint of Y happens to be at 0, 2. Okay, let's find the midpoint of AC. Well, that's easy. Let's count it. 1, 2, 1, 2, 3, 4, 5, 6, 7, 8, 2, 8. Let's go 1, 4, 1, 2, 3, 4 is right there. Let's label that Z. And the coordinate of Z is at -2, 0. Okay, so far so good. Okay, now let's find out what the slopes of these are. Okay, so if I want the slopes of AB, BC, and AC, let's just count them. Okay, so AB, the slope of AB, let's figure out what that is. So AB is going to be up. Looks like it's up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1. So the slope of AB is 1 over 1. Okay, up 1 over 1, slope of AB. Let's find out what the slope of BC is. So BC looks like it's down 1, 2, 3 over 1, 2. Because remember, slope is rise over run. Slope is rise over run. You know that. So let's do it again. Down 1, 2, 3 over 1, 2. Slope of BY, or BC, is down 3 over 2. And the slope of AC, let's check out the slope of AC. So the slope of AC is down 1 over 4, down 1 over 4, so it's down 1 over 4. Okay, awesome. Okay, now, they're mid-segments. Well, we need to draw in their mid-segments, so let's draw them. Okay, I've got the slopes of AB, BC, and AC. Okay, got it. Awesome. So let's draw them. Okay, so first of all, let's draw on this mid-segment. So if I draw on this mid-segment, right there, there's XY. What's the slope of XY? So the slope of XY, let's see, is down 1 over 4. Let's draw in another mid-segment. Okay. All right, I'll draw in the mid-segment here. Right there. So that's mid-segment XZ. So what's the slope of XZ? XZ down 3 over 2. So XZ is down 3 over 2. And let's draw on the last mid-segment. Last mid-segment is right here. Let's draw that in. And that one looks like, okay, mid-segment of YZ. So YZ, its slope is equal, looks like it's up 1 over 1, up 1 over 1. Okay, here's what I know. If you have equal slopes, you're parallel, right? So I got an equal slope here and here, okay? So here's what I'm going to state. I'm going to state that AB, so I'm going to say that right here, AB is parallel to YZ. Yeah, they look parallel, don't they? right? They look parallel, and they are because they have the same slope. Let's see, what else is equal? Okay, I got BC over 2 and XC. Okay, that same slope, so I'm going to say BC is parallel to XZ. Okay, same slope. And now finally AC. Well, let's see. AC is 1/4, negative 1/4, and so is XY. So we're going to say they're parallel. So I'm going to say AC is parallel to XY. Okay. Same slope. Okay. So we can state that. Okay. Now how about the lengths? Okay, to do the lengths, we want to find out how long this one is. We'd have to use Pythagoras theorem. Okay, but I can do that pretty easily. Okay. So if I use Pythagoras theorem between AB, it's like, see the right, I'm going to have a right triangle. Okay, so the length of AB, okay, I'll go slowly, but if I see a right triangle, I can use Pythagoras theorem. 1, 2, 3, 4, 1, 2, 3, 4. So it's going to be the square root of 4 squared plus 4 squared. I'm just doing Pythagoras theorem. Find the length. That's going to be the square root of 16 plus 16, which is square root of 32. Yeah, I could reduce that, couldn't I? I could reduce that if I wanted to into 16 times 2, which would be 4 square root of 2. Okay, I'll let you think about that for a minute, okay? Now, if I wanted the length of zy, let's do zy, okay, because it's supposed to be half. So Pythagoras theorem, up 2 over 2. So for zy, okay, I'll do Pythagoras theorem. Do you see a little right triangle? Let me go ahead and try and draw. Do you guys see a little tiny little right triangle in here? See a little right triangle in there? So Pythagoras theorem. We're going to go, all right, I'm going to go the square root of 2 squared plus 2 squared. All right, Pythagoras theorem, 2 squared plus 2 squared, square root of 4 plus 4, which is square root of 8. And you have to reduce that to 4 and 2. I get 2 square roots of 2. Hey, it is half the length. Well, good. It's supposed to be. It's supposed to be, okay? Now, let's do this again. Hopefully you're getting the hang of Pythagoras theorem. Let's do BC. So BC is this one right here. And I want you to see there is a right triangle. It's the easiest way to do the distance is to see a right triangle. Let me draw it out. Okay, see my distance? See my right triangle? I got a right triangle right there. So to do BC, the length of BC, let's see Pythagoras theorem. BC is going to be the square root, let's see, 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. 4 squared plus 6 squared. Okay, Pythagoras theorem, 4 squared, 6 squared. 16 plus 36, right? 16 plus 36, what's 16 plus 36? It's 52. Okay, and, whoops, 52, and I wrote 54, my bad. 52, and I think that, divide that by 4. Yeah, that's going to be the square root of, I'll squeeze it in here, that's going to be the square root of 4 times square root of 13. Square root of 4, square root of 13, I'm just reducing my square roots, which is 2 square roots of 13, okay? Okay, now let's check out BC. So here's BC, let's check out XY, okay? XY. Okay, let's figure out XY. So Pythagoras theorem, you guys kind of see Pythagoras theorem? I kind of draw my right triangle here. Pythagoras theorem, we've got a little right triangle right there. 2 and 3. So with Pythagoras theorem, okay, to find the length, and use Pythagoras theorem, square root of 2 squared plus 3 squared, right? 1, 2, 1, 2, 3, which is the square root of 4 plus 9. 4 plus 9 is 13. If it's 1 square root of 13, sure enough, it is half, right? It is half as big. This one's 2 square roots of 13. This one's 1 square root of 30. It is half a bit as big. And finally, we'll do the last one, okay? So what I haven't done is AC. Okay, let's do AC. And again, I'm going to use Pythagoras theorem. So again, I'll show you my right triangle. So if I look at AC, you see a little right triangle. If I want to find the length of that, the length of AC. All right, let's do it. Okay, AC will do then the square root. Let's see, it's 1, 2, 1, 2, 3, 4, 5, 6, 7, 8. So 2 squared plus 8 squared. 4 plus 64, right? 4 plus 64 is 68. I think 68 divides by 4. Oh yeah. So this will reduce. I'll show you my little reducing. It'll reduce to square root of 4, square root of 17. It really does, which makes 2 square roots of 17. And finally, if this is AC, then let's check out XY. So the length of XY, again, we're going to use Pythagoras theorem. And hopefully you can see a little right triangle with XY. Okay, if I take my picture, got a little mini right triangle right in here. Okay, see my little mini right triangle. So Pythagoras theorem, I'm going to go, okay, a squared plus b squared equals c squared, 1, 2, 3, 4. Or it's going to be the square root of 1 squared plus 4 squared. 1 plus 16 is 17. Square root of 17. So it is half as big. So we just did a proof. Okay, we just proved it. Remember I told you that theorems have to have proofs. Okay, so here's what I proved. I've proved parallel because they have the same slope. Mathematically I proved it. Okay, and I proved with lengths that they are half as big, half as long, half the distance. So I've done a proof. Okay, now that we've done the proof, we can turn the page and let's use this. Okay, and you guys can pause this anytime you want to, have the substitute pause it, but right now I'm moving on because you can pause. Okay, so let's look at example 2. Okay, example 2, what we got? U, V, and W are mid-segments. So if the mid-segments, I know that this side is equal to this side. It's a mid-segment. I know this side is equal to this side. So I know MW and WN are equal. I know LV and VN are equal because mid-segment, that's right in the middle. And I also know UL is equal to UM because it's a mid-segment. Okay, I know that. I also know that things are parallel and half the length. So here's what I have to find. The question's asking me to do the following. So what I've got to do is LU is here, and VW, that's here. Okay, these have to be equal because if this is twice as long as this mid-segment, these two absolutely have to be equal. They have to be equal because this is half the length of the entire thing. So let's use that information and do it. So I know that LU is equal to VW. I know that. LU is equal to VW. So LU is 2x minus 10, and VW is 8 minus x. Okay, so then I'm just going to solve for x. I always like to get rid of the smallest x first. Plus x, I get a 3x minus 10 equals 8. Plus 10, right? I get a 3x equals 18. Divide by 3, and x is going to equal 6. Okay, now, if x is equal to 6, that's not the answer, because the question is find LM. So I want to find LM. What I'm going to do is plug the 6 back in. So let's plug the 6 back into here. Okay, so I want to plug it back into here. Okay, so this is going to be a 2x minus 10. This length, LU is. So let's plug it in. So I'm going to take my 6, put it right there. Okay, so I'm going to go 2 times 6. All right, I'm going to go 2 times 6 minus 10, which is 12 minus 10. So this length is 2. Okay, so this length here is 2. Okay, so this is 2, which means this is also 2. So the whole length is 4. LM must equal 4. Okay. All right. Let's shift down. Okay. So the perimeter. I want the perimeter of DEF. Let me mark it. DEF. Let me mark it. Okay. DEF. DEF. Okay. This is not that hard. We're just going to take half of everything. Okay. So I know that AC is 76. So 76, I'm divided by 2. So if AC is 76, then DF is 38. I just took half of it. 76 divided by 2, and I got 38. So this side's 38. Okay. I know AB is 26, so FE is half of that. That's 13. Okay. I know BC is 90, so DE is half that, which is 45. So if I want the perimeter, what I'm going to do is add them all up. I'm going to go 38 plus 45 plus 13, and that equals 38 plus 45 plus 13, and I get a grand answer of 96. Okay, so you can pause the video while everybody gets out the journals, and then we'll start the journal up again, all right? Okay, assuming you guys are back, you got your journals in front of you. So here it is. Here's our theorem, right, which we've already proven. One more time, if it's a theorem, it's a math rule that can be proven. So it was a pain, but we did our proof, our first theorem. We actually proved it. We proved it was parallel, and we proved it was half. Okay, so it is a theorem. It's a math rule that can be proven. Here it is. DE is a mid-segment. Yes, we've proven that because it's half its length, and they're parallel. Okay, so we know that DE is 1/2 of AC, and that's what we did in our proof. Okay, so parallel and half the length. Okay, easy. We did the proof. The proof is here. I know you don't like proofs. Most kids don't like proofs. But we actually proved this theorem. Now, turn the page. Let's take a look at it. It's pretty easy. Okay. So you ready? Mid-segment. Half as long. Okay. Turn the page. We're on page 210. Page 210. And pause if you're waiting for kids. But this is easy. 28. What's x? 28. What's x? Yeah, 14. Easy. Okay. DE is 15. What's x? 15. What's x? Yeah, well, if this is half of this, it'd be twice as long, or 30. Good. Okay. 3. All right. Find x. Well, if this is a mid-segment, it cuts it in the middle, which means if this is 9, this is 9. Okay. And number 4, we can do that quickly. All right, let's see. I'm going to go ahead and put my graph down. Let's see. Let's try putting it. I don't know if it's going to fit. Might have to do it on a separate sheet of paper. Maybe. I might do this on a separate sheet of paper, and then I'll be done. Okay? Real quick. Almost done. Let me put this on a separate sheet of paper, and we will be done. Okay? We're going to find the mid-segments. I can do that. I don't think their paper is big enough, but you can try it. Maybe if you go by 2s, it might fit if you guys go by 2s, but I'm not going to go by 2s because I don't think it's going to fit. I'm going to do it on a separate sheet of graph paper, okay? If you want to use your book, go ahead, but you might want to go by 2s, but I'm going to do this one, okay? Are you ready? Let's find the mid-segment. -5, 1, 2, 3, 4, 5, and 6. 1, 2, 3, 4, 5, 6. There's A. B is 3. 8. 1, 2, 3, 4, 5, 6, 7, 8. There's B. And 1, -4. 1, 2, 3, 4. Yeah, I don't think it would have fit on their graph, and why they made such a lousy little itty-bitty graph, I don't know. But anyway, the graph paper worked just fine for me because it's going to be easy. Okay, if we want to find the mid-segments, all I got to do is count. If I want to find the mid-segments, all I have to do is count and go halfway. Okay, so I want the mid-segments, okay? So I'm going to count and go halfway. So let's do it. So, here we go. I'm going to count. I'm going to go up. 1, 2 over 1, 2, 3, 4, 5, 6, 7, 8. So it's a 2, 8. Let's go 1, 1, 2, 3, 4. There it is. Call that x. There's my midpoint. Okay, how about C? AC. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6. 10, 6. 1, 2, 3, 4, 5, 1, 2, 3. Let's call that y. BC, let's count. 1, 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 2, 12. Let's go 1, 1, 2, 3, 4, 5, 6. Let's call that Z. I'm going to draw my mid-segments, and I am done. Once I'm done, the substitute's going to pass out homework. I expect you to work on the homework in class. Don't goof off, but there's my mid-segments. There they are. Ta-da! And I am finished, okay? You can pause, you can rewind, you can look at it, but there it is.